Well, it's great to be here. I'm just going to get started and not worry about the introduction. So I have one slide to share with you. 80% of the AI ML projects fail to deliver the intended ROI. Now you're going to tell me, Afzal, please cut the crap. Sam Altman came just a few days ago, wrote an essay saying that we are few thousand days away from having ASI. Guys, we are not talking about AGI. We are talking about ASI. What is the difference between AGI and ASI? You guys are really smart here, so I'm not going to go into detail, but we're talking about artificial super intelligence from his perspective. And I actually fully agree with him that we'll get probably a model that can reason at a PhD level and really have an ASI in a few thousand days. So what am I saying here? How come 80% of the AI/ML projects fail to deliver the intended ROI in the organization and in enterprise AI? We are trying to bridge that gap here today and probably give you a little perspective on why we might be failing there. But it's a negative number. 80% of the projects fail. But the total number of projects are off the roof right now with AI in consumer internet as well as at enterprise level. So even if the 80% will fail, we're going to improve this. Believe me, we together are going to improve this to 60%. In any case, for IT projects, the number is 40%. 40% fail to deliver anyway. So we are probably going to go from 80% to 40%. But the total pie is increasing. The total pie is getting bigger and bigger. And hence, you are going to see the revolution of AI that we are already in, and this is just getting started. So we'll touch base with some of the challenges within the artificial intelligence at the enterprise level and give you a little perspective of how our company is trying to solve that problem. And hopefully you will go with some perspective that you may encounter in your future lives, in your future professional lives working for enterprises. So the outline is I'm going to review some of the current data and AI trends. It's going to give you some stats. We will talk about the limitation for enterprise AI. What are the holding factors? Why we can't deploy, develop and deploy AI at the enterprise level the way we are able to do for consumer internet, the way we are able to do with ChatGPT or Claude or any one of your LLM that you might be using. Right? So there are some challenges with enterprise AI that we'll touch base with the limitation and how do we solve the fluid property prediction problem at our company with AI by combining it with physics and domain expertise. Because that's when you get to the enterprise level, when you get down to the level at which you want predictions and forecasting, you need to have great knowledge and understanding of the domain that you will be working with, and you need to probably apply physics as well. That's where you can actually unlock the maximum potential of AI within those enterprises. And what is required for sustainable AI solution, we'll talk about that at the end, and hopefully we'll have a good talk, a good discussion. Now, I was told that this forum is more interactive, so feel free to interrupt me to ask questions. I will take a question or two. If it is very short, I will take it there, or I may park it. So I may stop you and say, hey, let's get back to it at the end of the presentation. Sounds good, guys? And pizza is not bad, right? It's great, right? Free pizza is always good. So thank you guys for being here. So here's the data never slips, a slide from Domo. This talks about how much data are we generating. Now, this comes from December 2023. I'm looking forward to Domo's report 12.0 in December 2024. You can see how many Airbnb stays we book in a minute is 747. How many Google searches we do? 6.3 million. By the way, that is plateauing out almost. ChatGPT is having a go at it, right? As we know, it was 2 million Google searches in 2013, just so you know. How much the thing that took my mind was WhatsApp, 41 million messages sent. And Taylor Swift. Yeah, who mentioned that? That's great, right? Taylor Swift. She's a billionaire for 8 reasons. Who is that exactly, right? Let's talk about the emails. Emails. People send 241 million emails in a minute. Now you might say that's a crap. It's actually not crap because there's a lot of those junk and spam that you and I get, right? That's part of that 241 million, right? So yes, it's the right number. You're looking at the right number. So you look at the data that is exploding in the world, and the enterprise data has got different problems and challenges. They're trapped mostly inside, right? And how do we take this enterprise data out is one of the things that we will talk about. So how many days or months it took for ChatGPT to reach 100 million users? 2 months. How many months did it take for Google Translate? 78 months. Spotify, 55. Pinterest, 41. And by the way, somebody was telling me the other day that Thread actually blew this number out of the window. Threads from Instagram, but that's different. Yeah, you might be wondering what is Threads, right? Me too. I was wondering a few days back what is Threads. But yeah, we are living in that age of AI exploding at the consumer level, thanks to ChatGPT, thanks to LLM, and thanks to Gen AI. Now, let me break it to you. AI is not new. Many of the experienced people in the room know it very well. AI is not new. It's just that we are having this new revolution thanks to the LLM and the ubiquity of LLM, so to speak, or how LLM and Gen AI has become so ubiquitous thanks to the power, thanks to the compute power, thanks to NVIDIA, as you guys know. But we're not going to go into that detail, but I just wanted to give you this idea that this is exploding, whereas the enterprise AI still struggle to get to that level. Please hear me again. I'm not saying enterprise AI is struggling. Enterprise AI is also exploding, okay? But it's not at the level that what we are seeing at the consumer AI. Is usually the lag between the two. And once you get past that lag, I think you will see the similar explosion in the enterprise AI as well. So, Nobel Prize in chemistry, in physics, who are this given to? Those scientists, great scientists who applied AI successfully. So this tells you how you can club domain expertise and AI to unlock the maximum potential that AI can give us. Right? This is just a classical example. It's timely, and that also goes very well with our understanding of how we can apply the domain expertise and physics with the AI and get to the level that we all want to be. So Gen AI hype is almost over. This is another bad news. It sounds like bad news. It's actually a very good news. Generally all the hype, if you study all the hype cycle, you go back to, the tulip, or you go back to South China Sea, or you go back to the cars, or you go back to computers, or you go back to smartphone. It always starts with big hype, right? And then the hype dies down, and then the acceptance come in. There is a despair. I'm going to show you in the Gartner hype cycle. So what do we have? The data here. So if you look at the max hype that the ChatGPT had, this is, by the way, ChatGPT data. This is not just Gen AI data. We had 1.6 billion users, or 1.8 billion users, number of visits actually, in April 2024. Right now, we are at 132. So almost 90% down. This is good. Okay, this is good because the initial hype is probably way past us, and now the real work will start, or the real work will begin. The same way, people's bounce rate is 87.79%, and people just spend 59 seconds. So they get the answer and they move on, or they just check the ChatGPT out for a few seconds and people move on, right? But this is good. Those who stay, they stay there for a reason, which is always good. So that's the hype cycle that I was alluding to in my previous slide. That you always have the peak inflated expectation, then it drops down, then the reality kicks in, and then you have the trough of delusionment. So you might hear that delusionment in few more months now, maybe a year, hey, this AI hype is over, this AI revolution is over, blah, blah, blah. Don't listen to that. AI revolution is here to stay. And I think we are just at the beginning of many, many great things for humankind. Yeah. Now you might say, hey, what about the jobs that may get replaced? Yeah. Well, the best line I heard about the jobs is that your job will not be replaced by AI, but it will be replaced by the person who knows how to best use AI. And that's the best line I heard. And jobs will change, of course. So don't worry about this. We are going through big change, and we will be going through it. Humankind have always been very resilient and have accepted the change very well, and we will do that same. That's why we are the best species in the world, right? So I have no doubt that we're going to go through this together in a great way. So once that trough of delusionment is over, then you start getting the slope of enlightenment. Oh, I can utilize AI here. Oh, I can utilize AI there. And then the real use cases come out. Real people get to work, and real use cases come out. I think we're going to see that very soon with the LLMs and Gen AI. As per Gartner, they say we have passed that peak of inflated expectation. And then we'll have the standardized process to aid the implementation. So it will become more norm, more standard. When it becomes more norm or more standard, that's where the enterprises AI use cases kick in, right? And you will see that very, very soon, that many companies are able to do great things with AI. Not just efficiency, by the way. Just efficiency is a good thing. Having a good productivity is a good thing. But I think we're going to unlock many new horizons that have not been possible before. I want to actually mention here, people, irrespective of the politics, please leave the politics aside and talk about science only. AI was greatly used in mRNA vaccine. Do people know that they actually created, the Moderna created the protein spike for the vaccine in just 2 days, after getting the SARS-CoV virus RNA, RNA from China. On 5th January, they came in just 2 days, scientists put together, because they had the great AI going. Same thing at BioNTech, by the way. And that's why these two companies, Pfizer, eventually, BioNTech and Pfizer, that's how these two companies actually won the race out of 180 companies going after the vaccines. Okay, so AI has been used much before at a grand scale, much before the ChatGPT, just so you know. And this is just the most recent example. Okay, so having said that, Gen AI is not the only AI, right? If you think that that's the only AI, well, good, you're just getting started, okay? And there's a lot of things that goes with the AI. For example, you have the non-generative machine learning, you have the rules and heuristics. That's where the maximum forecasting and the predictions come in. The optimization, right? So you have to optimize your processes. You have certain processes in your industry that you might be following. Now, you might be here, most of you might be computer science graduates. So you might not know a lot of things happen in those industries because you do not have the domain knowledge. So the best thing to do is that when you work for enterprise and when you work at enterprise AI, you have to start working hand in hand with domain experts. You have to start working hand in hand with the people who understands the physics behind those processes. And that's how you will be able to, help them. It's not going to be, oh, I can do this Python code overnight and up we go. Great. Tomorrow morning, I'll have a solution. Yes, you may have a solution to part of a small problem. But when you're trying to solve a bigger problem, you got to listen to your business people, and you will have to work greatly with your domain experts. I can't stress enough on that part, how this is how you will actually maximize your potential, and of course, AI potential for humankind. So yeah, Gen AI fails in prediction and forecasting. Why? Because the prediction and forecasting require a lot of this data that you should have in those enterprises. So I'll just take my example of fluids characterization data. We come from the world where we do the measurements of fluid properties, and we try to apply AI on those fluid property measurements to do the prediction of the future fluid properties. So that will save the cost for our clients. They will save the cost of fluid sampling and analysis, for example. Now, if you look at ChatGPT, it's been trained very well on ChatGPT is just an example. You might get tired of me saying this, but that's a leading product. But Claude or Gemini or anything that you like, okay? Any LLM, Llama for that matter, any models that you like, they're trained on the consumer internet data, mostly, so far. Right now, you can take this model and you can actually train it on your data set as well. But that's where you will be utilizing what we call as global modeling approach, right? So there are two problems there. When you try to apply the Gen AI or LLMs for that matter, or global models for that matter, they're all similar in the same ballpark, so to speak. And you try and say, hey, I'm giving you this data, and I'm going to speak for our area, that you give a fluids characterization report and say, hey, this is my report. This is 60-page data. Can you predict me the bubble point pressure? Now, I'm going to get nerdy here with you. You might not understand what I'm talking about, but you will get the gist of it. Can you predict me the bubble point pressure? Yeah, it will hallucinate. We all know AI hallucinate. It will give you some data, but it will be wrong. Why? Because how many of these fluids characterization PVT reports are available in the open source, in the open market, which the LLM or the Gen AI has seen? Not much, because all of these data are trapped inside the organization that own. And by the way, these organizations are getting more and more protective of the data that they got. They have to become protective, right? They can't just let it go at it, because whatever happened on consumer side, from the internet, that can't happen to the data. So they're going to be protective of this. So then AI or the LLMs or the models, the global models, as I say, will hallucinate and give you some number. And those numbers will be wrong. For sure, it will be wrong, because they are not trained on enough data set. So it's not its fault, actually. It's our fault that we are asking for AI to do too much without understanding what has been in the mechanics in the background of those models. Then you say, hey, AI is, sorry for my language, crap. Oh, AI is hallucinating. No, it's not the AI which is hallucinating. It's our understanding of those models. Are we asking for that model to do too much? Right? And that's where I think one of the slides will come in. We'll give you an example of how you can actually solve this problem. And that's why the predictions and forecasting, right, becomes very, very undoable, so to speak, as of now. Now, you might say, hey, I can do great things with AI. I mean, I go to Delhi or Perplexity or wherever you might be going to, and one of my favorite examples is I like sea turtles. So if I tell Delhi, hey, do a nice picture of a sea turtle in a blue water with sun rays coming from the top, it will do a great picture. Why? Because how many sea turtle picture that it has been trained on? Plenty. That's not the case for enterprise, enterprise solution. That's not the case for very specific prediction cases that you might be solving. So you might see this disconnect and say, hey, either you might take this way, saying that it's crap, AI is crap, it's all hype, or you might say, hey, I'm not able to do this. I need to actually work on this further. Take the second route. I need to work on this further, and how we can, build those models which are going to be good at predictions and forecastings, etc. And that's what we try to do in our company for the use case that we gave it. So you are going to see probably a big, actually, I would say AI 2.0 revolution, so to speak, where you will see the companies like us come up with deep domain expertise and say, hey, we're going to apply AI. We're going to build our own AI to AI models, right? By applying the domain expertise, by applying physics in it as much as possible. And then we're going to give the solution. And the packaging, finally, the packaging is going to be very, very important for those deep domain expertise companies like us, saying that, hey, we can actually solve this problem and come up with real good ROI and hopefully bring this 80% number down. That's what you're going to see. Now, these two things are going to happen in parallel. What? Number one, the horizontal expansion of AI that you're going to see. AGI is going to come, ASI is going to come. Don't worry about it. They're going to come. Now, that's all on the consumer side, on the consumer internet side. That's all on the internet side. At the enterprise level, I think you will see this, companies with deep domain expertise working together and trying to leverage the knowledge and the compute and the power and whatever we got on the other side. And these two things will go hand in hand in parallel. That's what we think. That's what our perspective is. We might be wrong, like anybody else. I mean, so what are the problems? How do we solve the real problems at enterprise level? How do we tackle the data that are trapped inside the enterprises? So you got to go, make your AI solution and deliver them at that level. So your delivery mechanism also becomes very important with their own private cloud, and it's not accessible. The data is not accessible to others. And I think that's the way to go. That's how we should be able to solve the problem. What about the data when it's not enough or suitable for Gen AI or global model? That's where you will need to develop local models. And that's one of the things we do at Fluids Data. And I'm going to show you. Before I go in this, I brought this from mid-2010. I think it's still valid. It's a very, very, very interesting graph that is this guy Taras got and from Gartner. So you have the data, and if you look at the past data, that's all descriptive. You can describe what is the pattern, the past data, etc. But when you put it with the foresight and future with the data, that becomes predictive. But when you put in the intelligence, that's where the domain expertise come in, right? That you start putting intelligence, that becomes prescriptive. That now it's going to tell you, not just diagnose like what problem you may have. Hey, this is what you should be doing, right? And that becomes more prescriptive. So if you look at from hindsight to foresight, if you look at the optimization problem that I talked about in my previous slide with Gartner, saying that the predictions and the predictions and forecasting is difficult and it's almost impossible with the Gen AI local models now. That's where you go into the foresight, right? That's where you go into the prescriptive analysis, right? And that's where the optimization comes in. And that's where there's very few data, they're trapped inside. You need to bring them and apply your AI model more locally on those data sets. Okay, so next slide. So how are we solving this problem? I'm going to bring a few examples. Do we have any questions so far? I know we are at 12:26. So just wanted to check if there's any questions so far on the generic. I'm now going to get a little bit nerdy with you guys and go into a little bit more details of how we solve this type of problem. This is just an example. Yes, sir. Right. Yeah.
So just like reinforce the fact that that's a supervised learning problem, and using Gen AI is the wrong thing to do.
Exactly. Thank you very much, sir. I think for the Zoom audience, I'm going to repeat your comment because they can't hear you. So, great comment for the room here. That's what Gen AI is. The point is very well taken here. That what Gen AI is actually essentially supervised learning only, or kind of. That's what you're saying, right? Yes, there are two different things. Okay, so that's what you're saying. There are two different things. And the supervised learning is where the real AI and the predictions and predictive things come in, and that's where you guide AI and you supervise it. You're absolutely right. That's unsupervised versus supervised. I think I have a slide on that. I may have a slide on that. Let's see of where it fits. But you're absolutely right. Is the supervised learning where the maximum optimization problems or predictions problem can be solved. Very good. So which AI model which ML model to use? This is a classical question for us. What ML models to use? These are all the ML models. These are all generic global models, so to speak, right? And these are the laundry list of models that we have available. So what do we do? So I'm going to talk about the limitation of the global modeling approach. We're going to take a very simple example just to convey the message. It's the only simplistic example, by the way, of a sinusoidal wave, right? If you have some sort of sinusoidal system, and if you have that sinusoidal wave, and what you don't have is, you don't know whether it's sinusoidal or not, right? What you have is just these observations, right? These are the observations that you have, which are with the error bar. And you can say, yeah, that's, you need few data points, or you need rather a lot of data points to cover the entire range. And then you say, okay, this is my 95% confidence interval limit. Okay, y equal to fx, solve this problem and predict it in future, for future. Sometimes, depending on how noisy the data is, right, you can get the prediction completely out of the bound of 95% confidence interval limit, right? And that's a classic. This is a very overly simplistic example, guys. This just to give you the message, or just tells you the message how a simple problem like a sinusoidal wave cannot be modeled very well by AI, because it depends on the data. So what happens next is that the more the data, the less the uncertainty. Of course, the less the noise, the less the uncertainty. And these conditions are often not met. In enterprise AI, just now extrapolated to enterprise AI, you do not have enough data set. If you do not have these red dots, which are enough, and which has got higher error bars, how are you going to solve this problem? Well, surprise, surprise. Why are we asking for this particular case, right? Why are we asking for data and AI to do too much? Don't we know that this is sinusoidal wave? Don't we know this function? Now, you would say, hey, I don't know that. Well, that's where the domain expertise come in. If you're trying to model this with domain expertise, you will know that this is sinusoidal function. And now you put that constraint of sinusoidal function in your AI model, it will do great. Even with fewer and fewer data, it will do great. So we ask ML to discover the physics that we already know. And if we do that, that's where the unsupervised ML start failing. That's where the global approach of the AI modeling start failing, right? And that's just a very simple example. I hope I've conveyed the message to you with a very simple example of how we can marry the knowledge of physics and the knowledge of your domain with AI, and with much fewer data set, you can do that. So physics-driven AI model is, so this is our philosophy. What do we try to do? How do we build our model? So we don't build our model just based on what AI can do, right? We build our model. AI is an aid for us. Okay, it's a great aid, by the way. So how do we do? How we think of, we try to mimic. If I'm the domain expert and I am the AI or I am the program, how should I think, or how will I think to solve the problem of predictions and supervised machine learning for that matter, right? That's where you bring in those two things, the domain expertise and physics. I can't emphasize these 2 points enough, right? Because that will be the difference between the successful AI project and non-successful AI project when you're looking at the enterprise level with fewer data set that are also trapped inside. So this is just an example. So what do we do? How do we go about building our AI model? We go about building our AI model with fluids composition, because the fluids composition is like your DNA, right? So I have certain DNA in me, you have certain DNA in me, which will define what color of eyes you will get, what color of hair I will get, whether will I lose my hair or not, etc., etc. That's in my DNA. It's been passed on into my DNA. Similarly, the fluids composition in our area is what define the fluids properties. The fluid properties are defined by the fluids composition. So we go back to the basic and take the fluids composition as its fingerprint or DNA, and then build the model on top of it, right? Rather than asking that, okay, this is the data, unsupervised learning, as one gentleman said here, rather than asking for it to decoy this, or rather than asking to find out all these patterns. So we know many patterns already. The fluid composition is one of them, and we try to build our model by utilizing that information. So then you come up with your clusters in galaxies, right? So okay, you build your KNN, your K next neighbor approach. with your local approach. You build your clusters and say, hey, within those clusters of the given data, I can do my predictions very well. If it's outside of that cluster, go and get more data for me. I'm not going to do wonder for you, right? So our AI model should not hallucinate just like the Gen AI does. That's where we come in and say, hey, we know the constraints of our model. We know the boundaries of our model, and we got to be honest with it, right? Do not go with the hype. Just be honest and say, this is where we are going to be able to do all the predictions and all the forecasting very well because we have enough data set and because we applied our expertise on top. So this is another example. So how will I build a model from ground up, right? So if I have a fluid with X1 and I have the new fluid which is coming in with X2 with similar compositions, right? If it has got similar compositions, it should have similar properties, right? So all the slopes and sensitivities get defined from my domain expertise, and the neighbor must exhibit similar composition, temperature, and characterization, right? That's where we say, okay, this has got similar properties. Now you have another variable with the temperature in our area. So how do we go with that? We call it something called equation of state. So equation of state is actually a very well-established physics. Some of the great work was done actually at U of A with Pang-Robinson equation of state with Dr. Donald Baker Robinson, who was the U of A chemical engineering head in 1960s and 70s. So he has developed those equation of states, and there's so many other people who are developing on top as well. Well, we put that equation of state as constraints and as the domain knowledge on top of the AI, right? So then you take care of the pressure and temperature dependencies on top of the compositions and the difference between this. And then after we have done all this, we say, okay, that's my next slide actually. After we have done all that, we say only the blind data-driven ML model to capture anything that is left behind the domain experts. So we aid AI, we take the aid from ML, say, okay, whatever I have missed on this, right? So you build it from ground up, and that's why those models now require 1/10 of the data points that you would require, or even less sometimes that you would require by the global model. But then we got to be honest, where we say, hey, outside of these ranges, because of this data, let's say if you're a client A and it's got one cluster, we are not going to be able to do the predictions for the new data set that comes in for predictions, which is outside of that cluster. Mr. Client, go back and get more data, because this AI, even if we applied our domain expertise and physics on top, it's not enough, right? And I think that helps. I think this is the slide that I was referring to with the unsupervised machine learning and then the reinforced learning. So can we introduce physics? Why not? Right? I'm going to give you two more examples in two more slides next, and I'm going to end this talk. And how do we establish physics? And then the blind spots is taken care of by the ML model. Now, these are just two examples that I could talk about, when there are many things that we are working on right now that is not out in public yet, but soon, we'll be able to publish some of our work, and hopefully you will see it in future from our side, that how we are helping and building those physics and the domain expertise. So here's an example of a team built this in early 2010s, where we had the team had a problem of getting the GOR from downhole composition measurements. So that's called gas to oil ratio, right? And then you have a reservoir fluid. When the reservoir fluid comes out at the surface, right? We're talking about oil and gas. When it comes out to the surface, it goes into two phases, okay? So if it is oil, the gas will come out. If it is gas, then the liquid will drop out. Why does that happen? Because at high pressure, high temperature, you have those two phases in a single phase because of the pressure and temperature that you have downhole. When you get to the surface, the pressure and temperatures are different. So you get the phase split. So we know the phase split. We know this knowledge. We have this knowledge. So why would we ask AI to actually redo this for us based on the data? No. AI, you're giving me, we have the data set. We're going to apply this knowledge and do much better AI than unsupervised learning AI, for example. right? That's where we better introduce the physics. We know the light components are in the flash gas. We know the heavy components are in the flashed oil, and we know the ratio. And I'm going to show you a little bit with the equation here. We predict this with some equations in it by building in physics, right? So now with a very limited set of data, you can do much better predictions with AI. Our second example is the carbon sequestration example, right? So we have a CO2 problem. The world has CO2 problem. Now CO2 storage and CO2 sequestration is a big deal, right? Many oil and gas companies try to solve this CO2 problem by twofold. One is just the pure injection back into the reservoir. One is to actually back to the reservoir where they are producing, right? So that's called CO2 enhanced oil recovery. So you can put the CO2 back, and that can actually drive more recovery of the oil because it can strip off some of the components from the lighter ends, and the CO2 will come back again. So it's not going to be 100% what CO2 you put back in, you put it back into the ground. You will get some CO2 out along with the oil, but you will get actually more and more oil out, and CO2 will be trapped behind, right? So you will not have 100% efficiency. So we know that phase split of CO2 in this particular case, where the red zone is, we know that red zone is a single phase region. We know where the green zone is this two-phase region. And if you were to rely on just AI and data, you might get the data oscillating here like this, right? With oscillating boundary. Now that oscillating boundary can throw you off with respect to your AI. But we know the physics. We know from equation of state what this number is or what this curve is. Of course, you need a lot of experimental data to have that curve. Once we have that curve, also understand the curve changes. You see the slope is changing here, and the slope changes much different way here. If we ask AI to do this, just pure AI to do this based on the data, you would just simply fail because you never have the luxury of those many data set available. So what do? We put in the equation of state and say, hey, we know this behavior based on few data set. We know the physics. We built this. Now with much fewer data set, you're able to do much better predictions for CO2, carbon back into the reservoir. So that's just another example. And as I said, there are many more examples that we're dealing with. These are the two that I thought of sharing with you. So finally, it brings me down to the almost the last couple of slides. There are a few slides remaining, but this is last few. What is required for sustainable AI projects? So it's just not the data plus AI, right? It's data plus AI plus domain expertise with physics, of course. And you got to build this in a sustainable application, in a sustainable software. Because what happens, I mean, you guys are computer science graduates here, or undergrad. What happens is that you're doing a master's or PhD with great professors. You might be postdoc fellow. You do a great project, right? You may come up with 8-10 publications, and you move on to the next job, right? Similar things happen at the enterprise level as well. That there are, those 10%, 20% innovators, visionary people who do great work with AI, with the team that they can assemble in their companies, and then they move on to the next job. What happens? Your legacy is not left behind. And this is the hardest part, guys, right? So it will be good for you at the academia level, right? But change that mindset when you go to the enterprise level. Please change that mindset. Try to leave the legacy behind, because you're going to be changing your jobs as well. If you're going to be doing advanced AI with the team, how can I make a sustainable AI application solution? And that may not be very easy. It may not be as easy as, ChatGPT prompt is, right? Or any prompt for that matter is. That might be a little more difficult, a little more complicated, and never underestimate the power of that, right? A lot of companies underestimate the power of that. Oh, we can do software. Oh, no problem. It's just easy. It is not easy when it comes down to sustainable software solution you want to develop based on of your AI. So your AI models are going to be great. If you are not the application person, You got to work with, if you're a data scientist, you've got to work with the application people and make that software, please. I can't stress enough on this point when you go, work for some companies. You will hear from the industry, it's easy, it's okay, we'll just put an app together. No, it's not going to be as easy as you think. Because whatever knowledge that you have, whatever principles that you're applying, how do you communicate this back to your development team, the software development team, and how do you bring them out in a live breathing software? And that's the mistake that people do, especially great people do, because you are on to solving next problem. This problem is solved in your mind. This problem might be solved in your mind, but it's not solved for your company. It's not solved for the industry. It's not solved for your peers. Okay, so please pay attention to those things. Try and learn some of the things as well on the application side and how to work with others, right? This software engineers or software developers, you might, because you're a data scientist, you might, okay, fine, he can do it. No, please have some also respect going for each other, right? The communication respect, because you need to communicate that well. And that's what we try to do as well. In our company, we try to instill that culture, that your job is not done until a sustainable software application has been put in, which can be used for many, many years or many decades to come, so to speak, right? Have that long-term view, right? So yeah, with this, we try to provide the end-to-end solution. We try to unleash data that are trapped in our clients' database, in our clients' directories, in clients' PDF as well. OCR is something that, optical character recognition tool is something that people underestimate the most. It's actually not the OCR. After the OCR, how do you characterize and standardize the data? You got to standardize the data so that the data scientist 1, when he's looking at the data, what's the data scientist 2 when he's looking at the data, versus the developer 1 when he's looking at the data, versus the manager 1 that is looking at the data. You all need to be looking at the same data set, and that's where the data standardization comes in. By the way, there's a great study done before. I think there was a good one done by Gartner, I think, or something. Somebody said that 80% of your time goes in cleaning the data and making the data AI ready. That's true. We found this out, and we find this out. And although everybody knows it about it, everybody knows about it, right? I can see some shake heads here. We still don't do it. We don't account for it. We don't account for it in our AI projects when we build the AI projects proposal. That's why. It's one of the reasons, not the only reason, one of the reasons why those 80% of the projects fail to deliver the ROI that is intended, right? So yeah, we try to do this end-to-end solution, try to think of it from holistic point of view. And by the way, the holistic point of view, although everybody gets it, when you are at the heat of the work, when you are at heat of the delivery, when you are trying to put those proposals out and try to execute those projects, these end-to-end solutions become very, very difficult. Believe me, guys, it's very, very difficult for across the board, for across the industries, for across many skill set of people. It doesn't matter who is doing that. It's just hard. Okay. All right. So I'd like to thank finally the contributors of my great AI and domain expert team. With that, I'm going to end. Thank you very much for listening. Thank you very much for coming.